Welcome again. It's me, Amran Abdinasir, and this is my last project, which is about building a retail data pipeline. This project is from my last track that I finished in Datacom, which was data engineering in Python. So let's start our presentation. We're gonna start with the introduction. In this section, we will provide an overview of the key concepts and goals behind this important project. So welcome today. This shit. This shit not welcome. This is not it. Hello everyone, welcome again. It's me, Amran Abdinasir, and this is my last project, which is building a retail data pipeline. This project is from my third uh, track from Datacom, which was data engineering in Python. So let's start our presentation first by introducing the introduction. In this section, we will provide an overview of the key concepts and goals behind this project. This project will involve extracting, transforming, and aggregating and loading e-commerce data to analyze and supply and demand around holidays. The background of the company is Walmart and is the largest retail store in the United States. By the end of 2020, e-commerce sales reached 80 billion, 13% of Walmart's total sales, and public holidays significantly impact sales. The objectives of this project is to create a data pipeline to analyze supply and demand around holidays, and also conduct preliminary data analysis. In this slide, we can explain about the project requirements. The goal of this project is to build a data pipeline that extracts data from grocery sales table and additional data file in BRICS format. We will transform and clean this data, aggregate the monthly sales, load the results into CSV files, and validate the output files existence. And these are the goals that I just explained. These are the sources. The extract function. First, we have this function named extract. First, this function combines data from the grocery sales table and the extract data per GWT file, returning a merged data frame called merged_df. This is the code, as you can see. Second, we have the transform functions. These are the functions that we used, basically. The transform function takes the merged data file, missing numerical values using the mean, adds to the month column, filters row where weekly sales exceed $10,000, and drops unnecessary columns. The result is clean data frame called clean_data. And this is the code we used. And this slide, we're gonna explain the average monthly sales function. This is the function named the average monthly sales. This function takes the clean data and aggregates it to calculate the average monthly sales. The output is the aggregate data frame called aggregate_data, and this is the code we used. This is another function, which is load function we used. The load function takes the cleaned and aggregated data frames and saves them as CSV files. This function ensures that our transformed data is stored properly for further analysis. And this is the code for the load function. This is another function called validation function. This function checks if the generated CSV files exist in the current working directory. This step ensures our data pipeline has executed correctly, I mean. And this is the code for the validation function. On this slide, I'm gonna show the codes for the like the Python codes that I used and the results. This code we used to process average sales per month data. This is the average month sales per month code. And this is the result graph. Here's the line chart showing the average sales per month as you can see it. In conclusion, we successfully built a data pipeline that extracts, transforms, and aggregates and loads e-commerce data. The cleaned and aggregated data is now ready for further analysis. Future work could include deeper analysis on sales trends and optimizations of data pipeline for performance improvements. And this was the end of my last project. I I hope it was helpful and meaningful, and thank you so much, and see you.